Hey, 7th grade math students, Mr. Themes here, coming with another lesson. Today we're going to be learning about how to find the area of circles. The area of circles, lesson 16.2. So if you look at our learning targets for today we are going to be approximating area of circles, and then we're going to be able to apply the formulas to find the area. And this formula here, A equals pi r squared, area equals pi r squared, is going to be super important that we know how to use this formula and how to apply it to our problems today. We all know that pi, the number that we use for pi, is 3.14. That's going to be a very important formula for our problems today. For this first part, here we have a circle. It says a circle is a set of points in the same plane that are an equal distance from the given point called the center. The distance around the circle is called the circumference. So a line segment that goes through the center of a circle with both endpoints is called the diameter. The line segment with one endpoint on the center and the other on the edge of the circle is called the radius. What I want us to do for number one is I want you to label this blank circle over here with these words that I'm circling right now. So let's go ahead and do center, circumference, diameter, and radius. So first, this point right here in the center of the circle is obviously called the center. Label that now if you haven't already done so. The circumference then is this, like, it's the distance all the way around the outside of the circle. It's the circumference. That is the distance all the way around the edge of the circle. It's how far it would take to go along the outside. That's circumference. The diameter of a circle, as it says in the definition, it goes through one side of the circle, and I'm not going to draw a very straight line, but it would be a straight line through the center to the other edge. That is called the diameter. So I'll go ahead and write that here, diameter. Not great handwriting, but you can see it. And then finally, what we're going to need for today is what's called the radius. It goes from the center of the circle to the edge of the circle. That is called the radius. These are important vocabulary words you're going to need to know how to do today. So make sure you've labeled your circle. Now looking at number two. This number two, we're going to use this circle over here. It has a radius of 3 units. It's graphed. We want to estimate the area by counting the number of enclosed circles. So what we could do here is we could look at all the whole squares that we have, because every one square is basically like 1 unit. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 whole squares that are not cut off. And then we have some of these that are just barely cut off. So let's just, since we're just estimating, we'll call that 17, 18, 19, 20. And then we got to piece together these other ones here. So it's, let's see, we're at 20, 21, maybe these two together make 22, 23, 24, 25, these two make 26, this is 27, so we're right about 27, maybe since these are bigger ones we call it 28. 27 or 28 is a good estimate since we're just estimating the area of how many whole squares are here. That's what the area means. The area is the inside of an object, in this case of a circle. So it's the estimated area in square units. I want you to press pause and I want you to try to estimate the area of this bigger circle below by counting and just estimate that. So press pause and do that now. Okay, you could have found the exact answer using the formula, but for those we're just estimating. Now we're going to actually use this formula here. Area is equal to pi r squared to get a more exact answer for the area of a circle. So if you look at 4a, here we're given the radius, which is perfect because the formula that we need to always write down and start with is area is equal to pi r squared. So now we'll just plug in our numbers. I'll leave pi for now, but since we're given 9 as our radius, we can just plug in 9, always using parentheses and square it. Make sure you are showing all of your work in this. We can leave pi. 9 squared is 81. So now it's pi times 81. You can plug in 3.14 times for pi. So 3.14 times 81. And what we would get for that would be 254. You're going to need your calculator. You're going to want to use a calculator for this. 0.34. So our answer for the area of that triangle, or sorry, of that circle is 254 and 34 hundredths. Make sure you write that. Look at 1, 2, 3, 4 steps that we have here. I'll go ahead and show you B as well before I have you do the next one on your own. So again, start with your formula. Area is equal to pi r squared. We know that our radius, which is given in this picture, is 6, so I'll leave pi for now. Then we have 6 squared. So pi, 6 squared, 6 times 6 is 36. Again, we know pi is 3.14, but I'll go ahead and write it down this time. So it's 3.14 times 36. Use your calculator to get that, and you should get 113 and 4 hundredths. So 113.04 millimeters squared. Look at all that work. You should always make sure you have all that work written down and solved. Go ahead and press pause and do C on your own. For number 5, notice the difference in these circles now. Notice how we're no longer just given the radius, we're now given the diameter all the way across. So we really need to divide this into half because the radius is half the diameter, because the formula that we need is area is equal to pi r squared, or pi radius squared. So we plug in 10 in for r in this case. So we got to make sure we use 10 and not 20, because 20 is the diameter, we need to use the radius. So it's pi times 10 squared. 10 squared, 10 times 10 is 100. I'm showing all of my work. Make sure you always write all your work down. Some people like to write 3.14 down. You can if you want. You don't have to. But if you put that into your calculator, that'll be 3.14 times 100, and that would give you your answer of 314 centimeters squared for 5A. Press pause on your own, and I want you to do B and C using that formula and using the radius of those circles. Press pause and do B and C. Okay, number 6 now. Number 6, this is a real world example. If you have a drum and we want to find the area of the drum head, this top part here, the area of this drum head, we would need to know the radius. So here, all the way across, you can measure that easily. It's 14 inches all the way across. So if it's 14 inches for the diameter, then that means it's 7 inches as the radius. Start with your formula. Area is equal to pi r squared. Show all your work. So let's see, in this case the radius is 7. I'll plug in 7 in for r squared. We know that square of 7, 7 times 7 is 49. So now we'll do 3.14 times 49. Plug that into your calculator, and let's see what you get when you do that. 3.14 times 49. Let's use my calculator here. 3.14 times 49 is equal to 153.86. 153 and 86 hundredths inches squared. That's how many of those little squares would be inside of this. That's a lot. 153 of them would be inside of this if we found the area like we did to begin. For number 7, you have a picture of a coin, a penny. Find the area of that coin showing all your work. Press pause and do 7 on your own. For number 8, it says one of Rose's gardens will have a tree in the center. So this is a tree right here in the middle of the garden. So all this other stuff is garden around the outside, and she has a tree in the middle. The radius of the large outer circle is 4 feet. So from this center point all the way to the edge is this 1 foot here plus 3. That's 4 total feet. So the radius of the big circle is 4. While the radius of the inner circle of this tree part is just 1. Okay, so we need to find the area of the garden without the tree. So if we can find the area of this whole circle here, and then subtract the area of the tree, since the tree is not going to be a part of the garden, then we can find the answer of this question, the area without the tree. So let's first thing we'll do is we'll find the area of the tree. Okay, and we'll start with our formula here. So area of the tree is equal to pi r squared. We know that the radius of the tree portion is just 1, and we square that. So that's 3.14 times 1 squared. 1 times 1 is just 1. So the area of the tree portion is 3.14. Okay, but now if we find the area of the whole big garden, so area of the, I'll put the G for garden, we're going to use the same formula again, pi r squared. So pi, the radius of the big garden is 4, so 4 squared, that means area is equal to 16. So 3.14 times 16. Let's see, let's put that one into our calculator, and we should get 50.24. Now we're not done yet because we have to subtract these two to find just the area of the garden without the tree. So we would subtract 50.24 because that's the area of the whole thing minus the area of the tree, which is not part of it. And when we do that, we get 47.1. So that, my friends, is the answer to this question. You find the big area and subtract the small area, and that is the area of this garden without the tree. Similar question in number 9. Guys, do number 9 on your own. Press pause and do number 9, and then complete all the rest of your work in your IXL before you leave today. Good job, guys. Keep working hard.